We now move to session 3. It's our last presentation before the lunch break. It's about developing indigenous biofuel and biomethane for transport. We're delighted to welcome Julianne O'Reilly to the stage. Julianne is the Biofuels Business Unit Manager of the Biofuels Division at College Group. Julianne's presentation is biomethane, biodiesel and bio-fertiliser, decarbonising transport and agriculture. Julianne plays a key role in managing the operations at College Group, and under her leadership the division supports Ireland's transition to a circular, low-carbon economy by transforming food waste into high-quality renewable fuel, and she works closely with sector, service sector and government stakeholders to drive innovation around sustainable energy and waste management. So we're a bit late going to you, Julianne, but thanks for attending today, and we look forward to your presentation.
We'd just like to begin by thanking IrBEA for inviting us here today to share a little bit of our story with you all. So just to begin with, College Group is Ireland's leader in the circular bioeconomy, and as I go through the presentation I'll give you some information to support that statement. So it's a family-owned business founded in 1989. It operates across 3 sites in Ireland where we integrate innovation and sustainability across the full bioresource value chain. So we have a number of different divisions. We have College Proteins, which is a rendering facility, College Biofuels, our biodiesel facility, College Biogas, which is almost finished construction and will be launching in 2026. And then additionally we also have Soilworks Natural Fertilisers, which is based in Northern Ireland. We are Ireland's leading circular economy company, and what we do is we transform agri-food materials into a number of different valorised outputs. So we convert them into animal feed, into organic fertiliser, and also into renewable transport and energy solutions. So our vision as a company is to drive Ireland's transition to a low-carbon, circular bioeconomy through resource recovery and sustainable energy innovation. So this is just to give you an understanding of our company and how it currently operates. So this is our circular economy model. What you can see on this graphic are all our different divisions. So at the back in the centre of the picture you can see our rendering facility. We have 2 of those. We have a Category 1 rendering facility and we have a Category 3 rendering facility. One at our site in Nobber and one at another site in Cavan. From our site in Nobber we process byproducts of the waste products from the agricultural and food industries, and we convert them into 2 outputs, a tallow oil and a meat and bone meal. Both of those outputs are fuels for renewable energy. So on that site in Nobber we also have a 3 megawatt solar farm which can supply energy to the biodiesel facility. We also have our biogas plant under construction that will take some of the inputs that previously went into our Category 1 facility and that have better value in a biogas plant, and then also some of the byproducts from our biodiesel facility will also be suitable for our anaerobic digestion plant. So the tallow oil that's produced from the Category 1 rendering facility goes across the yard to our biodiesel plant where we convert it into biodiesel or fatty acid methyl ester. So just to give you a bit of background on the biodiesel facility, I am the business unit manager for the biodiesel. That's where my passion lies. That's why you'll hear the most about that today, I suppose, and I am here flying the flag for the liquid biofuels. We are also a very, I suppose, important component of the renewable energy sector in Ireland and as part of decarbonising and reducing emissions for Ireland. So College Biofuels is a leading advanced biodiesel production facility, and what we do is we process complex waste feedstocks. So it's waste-based feedstocks only. The plant was completed construction in March 2020, just as COVID hit, which obviously had its own complications when our commissioning team ran out the door and jumped on planes and left the country. However, we managed to carry on regardless, and we reached full production by March 2022. So we produce fatty acid methyl ester, which is biodiesel. I'll go into this a little bit more, but as such, it's just an important distinction, and that is why continually refer to it as biodiesel and fatty acid methyl ester. So it is used as a blending fuel for parties obligated under the RTFO scheme. It's nice to see Frank here and other colleagues from the Department of Transport that we work very closely with on these schemes and on the role that biodiesel can play in decarbonising transport. We have the capacity to produce renewable fuels both for use in road and marine transport. So it's important also that marine transport is coming into that section, and it's somewhere that needs to be focused on and prioritised. So we produce these from a variety of advanced and traditional feedstocks. So our plant alone has a saving of approximately 85,000 metric tonnes of carbon. So that's the equivalent to 45,000 cars coming off the road. So it's a very significant impact. The electricity supplied to our site is also 100% from the 3 megawatt solar farm that we have on site. So again, that leads to reduced carbon emissions being associated with the biodiesel. And 1 tonne of FAME biodiesel offers 90% GHG emission savings versus fossil diesel. So the current road fuel transport obligation rate is 25%, and the indicative inclusions, it is to increase to 32% in 2026 and to rise to 54% by 2030. So as you can see, they're very significant plans, and there's a lot to be done to provide that fuel to the sector. So in terms of the RTFO scheme and this biofuel, where does this biofuel come from? Well, the 2024 annual report from NORA answers all these questions. So in 2024, 7 different biofuel types, 18 different biofuel feedstocks from 71 different countries were used to meet these obligations. The key thing in all of this is that only 10% of those feedstocks came from Ireland, with a further 13% coming from the UK. So there's a significant amount of global feedstocks that are required to fulfill the obligation rate here within Ireland alone. In 2024, 471 million equivalent litres of renewable fuels, liquid fuels, were placed on the market. And again, that's the equivalent of 236,279 ICE vehicles, or 8.1% of the total ICE fleet. So when you look at it from that perspective, you can see the significance of the impact that the liquid biofuel sector in Ireland is having. Biodiesel and HVO, or co-processed HVO, accounted for 79% of that volume. So this is the first time you've heard me mention the word HVO. It is another renewable liquid fuel that is suitable for inclusion or to replace fossil diesel, but it is a distinct type of biofuel. And I think that's something that's missed by a lot of people outside of the sector, and it's something that Noel mentioned earlier in his presentation at the beginning, that there have been some stories in the media over the last number of months, years, referring to fraud in the biofuel sector and so on. But these issues are all related to HVO and not biodiesel. And biodiesel is the product that is produced indigenously in this country. So it's just important for us to make that distinction. The obligation rate, as I mentioned, is set to double by 2030. Is that an opportunity or a challenge? Well, it's both. It's a double-edged sword. Obviously, it's an opportunity for producers, but it also brings up a lot of different challenges. With increased targets, this will result in increased requirements, both for feedstocks and finished products. Both HVO and biodiesel will be required to fill that requirement. There is, all biofuels are useful and needed. Every single biofuel that's being produced is currently needed. However, there will be conflict there because both of these finished products are produced from the same feedstocks. So it's just important to be aware of that, and that's where I suppose our requirements come from. There is a protection in the national legislation that protects bioethanol. So bioethanol is what's added to your unleaded petrol. And currently the legislation protects for a minimum inclusion of 5.5% up to a 10% blend recommendation. But this bioethanol only accounted for 20% of the volume blended into road fuel in 2024, whereas the biodiesel HVO accounted for 79% of this volume. So there is no provision for biodiesel, no protection for biodiesel in the national legislation currently, despite the huge impact it's having on the vast quantities that are blended. There's also no distinction in reporting, which is why I can't tell you in clear numbers the volume of biodiesel versus the volume of HVO, but I can tell you that it's any product from Ireland is biodiesel. So what are the opportunities then in relation to the RTFO scheme, and what is it that we think is important? Well, there's only biodiesel produced by 2 indigenous companies, and these provide both local employment and they also provide a disposal route for agricultural waste, which is an essential service within this country and does play a role in the protection of both animal and human welfare. In terms of HVO, there is no HVO production facility in Ireland, and there's a variety of reasons for that, but there is some co-production that happens at Whitegate Refinery. So what we have requested on numerous occasions, and will continue to petition for, along with IrBEA, and one of the main things is a protection of the minimum blending value. So it's essential that the indigenous biodiesel producers don't become displaced by global HVO that can come in vast quantities from potentially supply chains that may not be as traceable or verifiable as the domestic supply chains. So that's one of the things that we talk about. You've heard Kenneth talk about traceability with his logging, etc. Traceability with any biofuel is essential to ensure that it is sustainable. The other, I suppose, opportunity with the RTFO scheme and indigenous producers is that obviously, for example, on our site we have fully renewable electricity, we've biogas coming down the market. Our GHG emission savings are higher than the GHG emission savings that could potentially be achieved on a biofuel from a different source that's being imported into the country. So it is an opportunity as well to promote the indigenous production and thereby gain in the increased GHG emission reductions. So just to give a quick insight into one of our other main business units, which is the biomethane facility that is almost ready to become fully operational. So by 2026 it will have a full operational launch. So this is co-localized on the same site in Nobber as the biodiesel facility, the solar farm, and the category 1 rendering facility. So we're very lucky to have all those renewable fuels on the same site and promoting this circular economy model. Just some of the features of the facility. It's a waste-based feedstock facility. We have installed automated depacking equipment that will allow the food waste to be depackaged. We have a flexible intake design, so it allows us to take in diverse feedstocks. We will valorize the digestate again. There was talk of digestate during the panel presentation, and the fact that 80% of the output on a farm from their anaerobic digester is this digestate, which holds precious, important nutrients that are required to go back onto the soil. So we have installed an ammonia removal technology to allow us to valorize that digestate out of our plant. And we also have plans for a CO2 liquefaction unit. So we have a grid connection that's contracted with GNI for export of the biogas onto the grid. The expected completion date for that is January 2026. And I suppose in terms of end uses for the biomethane, well, we can export it to the grid, both for thermal use and electricity. We have a significant gas requirement on site ourselves, both for the 2 facilities for heating, but also for the production of green electricity from our CHP units. We also have transport fleets. We have, obviously with the rendering facilities, we have a significant number of trucks on the roads. So that is also a route that we intend to go down, and it will be an outlet for some of the biogas. So just, I suppose, to summarise, our Nobber site is capable of generating biofuel, organic fertiliser, bio-CO2, electricity and biomethane, all from waste resources. So I think it's a good example of a single company operating in a circular economy model. That's everything. Thank you.
Thanks very much, Julianne, for that presentation. Very, very interesting, and it is a true example of the bioeconomy in action. And we reiterate the call for policymakers to ensure that indigenous biofuel production is somehow protected in the overall scheme by that some form of minimum inclusion requirement, and we've started our lobbying campaign on that, and we will work with our members on that particular area.